Hello everyone, you Dr. Zia Tahir here. This video tutorial is Truss analysis in ANSYS workbench and the 9-member plane truss. So that is a truss shown in the figure. So it has modulus of elasticity as 30 gigapascal and area of cross section is 20,000 millimeter square, and I'm assuming as rectangular cross section with breadth as 100 millimeter and depth as 200 millimeter. So required is deflection at each joint of truss and axial force in member under given loading condition. So this is a problem 2.2 from chapter 3 bar element, introduction to finite element analysis using MATLAB and Abaqus. Fourth lecture of my playlist ANSYS structural analysis. So this one is a little bit complicated compared to the previous one. So if you want to learn from the start, so you can go to lecture 1, 2 and 3. So steps for analysis of 9-member plane truss or highlights of this video tutorial. So step 1 is to start a project and must be static structural, then need to add material, then in geometry need to select geometry options, and then using DesignModeler I am going to draw that geometry, and then in the model need to go to geometry and then assign material and then mesh, and here is like how to change mesh numbering from default to your user define, and then applying loads and boundary conditions, and finally to how to get directional deformation and then axial forces and solution and then visualization of the results. Step in ANSYS mechanical is to start a project, and it's supposed to be a static structural project. So I am going to save that as 9-member truss. So here you are. So this is, you have ANSYS workbench, and you'll have here a standard layout of it, and then these are analysis systems in it. Okay, so you can view and you can reset workspace, you can reset Windows layout, and if you want to add any of the tab here, so with here you can add. So I'm going to start a static structural project, and here is static structural. So double click on static structural, and in the project schematic you can see that project static structural, and these are the 7 steps which I'm going to follow. So I'm going to save that model. So I saved that project as Truss 2D 9-member in the folder where I want. So now that is your project static structural started and saved. Next step is in engineering data need to add material, and it's a linear elastic material and need to add isotropic elasticity. So material has 30 gigapascal of modulus of elasticity and Poisson's ratio is 0.3. So here I'll double click on engineering data, and then a new window will open as you can see here, and there are several tabs here, and click here to add new material. So here click here to add new material, and I am going to name it as new material. So now once you have that new material, so it's created, you can see there is a question mark on it, and then from isotropic elasticity I am going to drag to that new material. So then you can see that here a few things highlighted. So units are in Pascal, so Pascal, and then 30 gigapascal, so 30 e raised power 9, and then Poisson's ratio is 0.3. So I'm going to add that, and once, so that is a new material and its mechanical properties from the linear elastic I have added. So once it's done, so I'm going to save that. So by click here, so you can save that material. Material is saved, so you can just close that window. Step in the geometry need to set geometric option and analysis type, and simple. So you can go click on geometry, and then here in the basic geometry options, here in the basic geometry option, so you have solid bodies, surface bodies. I'm going to uncheck that, and then you need to select that 3D. So although it's a 3D problem, a 2D problem, but I'm going to solve it as 3D. So now that geometry, so here you have geometry option and then analysis type you selected. Next step is to create geometry using DesignModeler geometry. So in ANSYS Workbench, there are three options. So right click on geometry, and then you have three options, either to import geometry from somewhere using, then you can use a space claim geometry or DesignModeler. So I'm going to select DesignModeler, and then for DesignModeler, a new window will open. That is DesignModeler. Here you can see design model, and then it has file, create, concept, and then here it has static, structural, and even in that there are two tabs, one for sketching and one for modeling. The plane truss, and I want to draw it in XY plane. So from here you select that XY plane and then go to sketching. So first I need to go setting and add grid, and then measure grid spacing based on that what we have here. So I am going to set as 1, and before that you need to go to change unit, and units must be meters, and then measure steps, so 10, and then snap I am going to add on, and you can see here now, so there are 10 steps in each of measure, and then I need to go draw. So this one I can draw using lines or I can draw using points. So first I am going to show you how you can draw a line using 2 points. So one point is on origin, the other one coordinates are 2.4 and 1.8. So I'll go here, and then I'll start a construction point, just a random construction point. So that is a random construction point, and then I'll go dimension, and then I'll add journal. So select that and then drag it, and then select again that and then drag it. So now here you can see at V1 and H2. So here V1, so that vertical, that point, its vertical coordinate is 1.8. So V1 I am going to select as 1.8 and H2 as 2.4. So now again here the zoom fit. So that is the point. So its horizontal distance from origin is 2.4, and then vertical distance from origin is 1.8. So then I can go again draw and a line. So then I can draw a line. So this is how you can draw a line using construction point. Next one, I'm going to draw this line and using dimensions. So I'll go line. So from this coordinate, I'll just draw any random line. So that is a random line drawn. Drawn a random line, then I'll go to dimension, and then I'll add horizontal dimension. So first point, and then second point, and then horizontal, and then vertical. So first point and then second point, and drag it into the horizontal. So that is H6 and V7. So that H6 horizontal must be 2.4, and then the rest one is this V7, it must be 1.8. Okay, so now you can see that. So that is being drawn, and then with their dimensions. Okay, so similarly, I'm going to draw rest of truss. So that is the whole truss is being drawn. So I can go dimension and then display dimensions. So here you can see that. So that is 2.4. This one is also 2.4. And if you want to add dimension, so just click on horizontal, select 2 points, and those, and then so that is 2.4, but it is over constrained because we have already add this dimension for point. So I'm going to just remove it. So then you can see that this is 1.8, that is 1.8, and then that one is also 1.8. So you can simply go to edit and then you can delete these dimensions. Okay, so model should not be over constrained. So means that you should not draw two lines, or you must not overlap it. So I'm going to display here is the grid. So still these one for the these dimensions are for from the that construction point. So here is the truss. Now it is being drawn. So sketch is finished in XY plane, and then I need to go here. So that is done using meter, and then I need to go concept, line from sketches, and then generate in the design modeler. So here first I need to go to the model, select that model, and then concept, lines from sketches. Okay, select that one. So here you have, and then you need to generate that. You can see that is a sketch, and then again is a sketch, and I'm going to rename it. Rename that a truss sketch, and then again concept, line from sketches, and then apply, and then generate, and you can see here, so you have truss sketch here. Sketch is done. The next one, you need to go concept and change units to millimeter, because dimensions are in millimeters. Cross section, rectangular, and then generate. So here I'll go concept, cross section, rectangular, and then in the rectangular I need to change units to now millimeters. And then there is, you can see here, there is already a square, and I need to change its dimension. So it is, its breadth is 100 millimeter, and its depth is 200 millimeter, and then you can see that it's there. So and then I'm going to generate that, and I can read as rectangular. So once cross section is being generated, the next one need to create part body. And for part body, so here you have part body, and there is a line body. Rename it as line body, and then here it's a cross section not selected, so I'm going to select cross sectioner. So that is a rectangular, and then generate. You can view its cross section, and here is the line body. So that is a line body, and then in a view, so you can go cross section solids, and then you can see its cross section. Okay, so that is a rectangular cross section is being assigned to that body. So now that all steps in the design modeler, so they are done. So you can save it. So once it's saved, you can close this window and see there is a tick on geometry. So now geometry is created and is saved. Step is in the model, you need to start a model. And here in the ANSYS workbench, double click on model. And if you double click on and say that starting mechanical, it will take some time. Now that is a geometry imported here. Okay, so that is geometry imported. And now here you have, you need to first check units. First check unit, and then assign material, and then you need to go to model type. So here you have geometry, and then here is a line truss body. So you can see line truss body there. And here down there, you need to material assignment. You need to change material to new material which you have assigned, and then the model type default is beam. So you need to change it to link truss. So now here you can see that new material and link truss is being added on the line body. Step in the model, need to create mesh, and for that sizing, geometry, select edges, and type number of divisions as 1. So then click on mesh, and then here is the sizing, and you can see here geometry selection here. Okay, so for geometry selection, need to go here and select edges. Using here select edges, and then mod is the box select. Okay, and then that whole model is being selected. So then apply, and then element size here, you need to go number of divisions and 1. So you can see that number of divisions are 1. So now this is meshing. You create mesh. I can go display, and then in the preferences here, in the display and in the preferences here, I can add mesh node number, element number, apply changes, okay, and then I can here display mesh. Oh. Just one step. So once edging is done, so you need to generate that mesh. Okay, and then here you can see elements and nodes on it. Next is to change mesh numbering. To measure mesh numbering, so you need to go number control, then scoping method, geometry, vertex, and then you need to add node number. So like as here you can see, so that is a node 6, node 1, node 5, node 2, node 3 is a node 1, node 2, node 3. So if you want to change default nodes, so then you need to go to mesh numbering, then numbering control, scoping method, geometry, select a vertex where you want to add a node, and then add node number. So click on mesh, and then mesh, and then here is mesh numbering. Okay, numbering control, and it says that what is the numbering control. So geometry selection, here I am going to select a vertex, this vertex, apply, and now node number, I am going to give it as node number 1. Okay, and then here you can see its node number is 1. So that is a node number 1. Then model, that is a node number 2, but here is a node number 6. So similarly, I will quickly repeat that. I'll go to the mesh numbering, numbering control, and then geometry selection. I'll select that node, apply, and then here is node 2. Okay, and then so I'll just solve it, and then you can see that node number 2 is being there. So that is node 1, that is node 2, and similarly you can change the other nodes. I have changed that node number 1, 2, 3, 4, and that automatically is 5. Here you can see vertex control 1, 2, 3, 4, 5, and if you want to change their number, so it will, you can change from here. So now what we have here, the node numbers, the same one will have here. Is in the setup, need to static structural, environment, support, and then displacement. So in this 5 step, so I am going to apply boundary conditions and then loads. So here in the static structural, and then I'll go to environment and then displacement. So that is a displacement, and here geometry selection, I am going to select nodes, apply, okay, and then I am going to set that zx is equal to 0 because it is a 2D model, but I am going to draw it 3D model. So out of plane any displacement, I need to fix that. To apply sports, so you can go either simply sported or displacement, and then scoping method is geometry, and then you can select a vertex on which you want to apply that boundary condition. Here node 6 is a simple sport, so I'll go static structural, and then in sport I'll go simply sported. So that is a simply sported, and then geometry, I am going to here vertex, and then you can go for a single select or a box select, is your option. I'm going for box select. So apply, So then here is a simple sport. And then node 1 is a roller sport. So for roller sport, I need to go again static structural and then environment and then displacement. So that is a displacement. So I'm going to select that vertex, apply. So because here is a roller sport, so then X component is free, only Y component is fixed, and then I can rename. That is here is roller sport, and that is a simple sport, and then this one is all nodes are selected so that 3D model is being converted into 2D model. Now both boundary conditions here I'm going to select. So both boundary condition A here is the roller sport, B is a simple sport, that is they are being applied. Is to apply load. So load can be applied by two methods. One is using a vector, and the other one is using vector magnitude and direction. The other one is vector using components. So I'm going to show you first how to use as vector magnitude and direction, and then the components. Loads are being applied: 10 kilonewton on node 2, 10 kilonewton on node 4, and 7.5 kilonewton on node 3. Apply 7.5 kilonewton on node 3, and for that again static structural, then loads, force, geometry selection. I'm going to select that node, apply, and now it is a vector, and its magnitude I'm going to add as 7.5 e raised per 3, and its direction. So for direction here, so I'll select this component, and then the direction is towards negative x-axis, and if you want to change it, so you can change from here. Okay, so apply. So this is load applied using magnitude and direction. So similarly, so I'm going to rename that as force 1, and then similarly I'll go static structural, environment, apply the other force at node 2. I'm going to select node 2, and then a vector, and its magnitude is 10 kilonewton, and then click to define its direction. So I'm going to select this one, this member, so apply. So that is at node 2, you can see that a force is being applied, and I'm going to rename that as force 2. And then the next one, there is another force of 10 kilonewton being applied at 4. So static structural, environment, and then force I'm going to apply at 4, node 4, apply, and then this time instead of vector I am going for components. So x component is 0, y component is minus 10 e raised per 3. So then you can see that a third force is being applied. So I am going to rename that as force 3. So by selecting all these three forces, so you can see the forces being applied, what is required in the model. Is a solution, and then I want to find deflection, and the directional deflection, and then you need to go to the solution, and then scoping method, geometry selection, and need to select orientation. There is a solution, and then there is a deformation. So I'm going to add a total deformation here, and then another deformation, directional deformation, and that is for x direction. So to find directional deformation, and here you can see that orientation is x. The next one, I'm going to add another directional deformation, and that directional deformation this time will be in y direction, and then here instead of x-axis orientation, you'll select as y. So now that is directional deformation in x direction, and that is a directional deformation in y direction. For deflection, total deflection in x direction and y direction, they are being added into the solution. Step to add axial force to the solution, need to go beam result, axial force, and scoping method is a geometry selection in the solution. And then for that, here you'll have that tool beam results, axial force, and that axial force is being added. Okay, so now for deflection and axial force is being added to the solution. Is to solve, and it's very simple. So just click on solution, and then you can see that here these are yellow, and then Now those yellow progress is going to turn, and it will take some time, and then you will see here green ticks, and that is the green ticks. It's mean that it is being solved, and then you can see that you'll have that some results there. Now you need to check what is the directional deformation. So directional deformation, so you can export that file, and that file can be exported as a text file. So let's say here is the directional deformation in X direction. So you can see the values there. Okay, so the maximum and minimum value you can see there, and then directional deformation, I can export that as a text file. Okay, so like as directional deformation X, so it is being saved, and then I can open it, and then you can see that here at each node, here are the directional deformation in meters. And similarly, deformation Y, so you can export as a text file, and then that is a directional deformation Y. So that is a directional deformation Y, and these are the values of directional deformation for each node. Is to check axial force, and for that one, results, go to probe and then select element. Here you have solution, click on axial force, and then on axial force, here you have probe. Okay, so and probe is not working here, so I go display and think, and then you can see the probe is working there. So these are member forces, and you can see here these member forces, their values, and then their units, and then maximum and minimum. Results, answers, like member force 1, which is in between node 1 and 2, so that is 8.333 kilonewton. So you can see that it is 8.333 kilonewton, and then between node 2 and 3, that is 3, and how much is it here? So that is 1000, and here you can see that it is 10,000, and here is 10 kilonewton. You can verify your results. Otherwise, you can export that file, or you can note the values, so it's your choice. So that's all done, and then summary of this tutorial. So this tutorial was for 9-member plane truss analysis in ANSYS Workbench. So first I'm going to show you that this lecture is, how is that lecture is different from the other one. So here I create geometry using construction point, and then I change that mesh numbering. So you need to start a static structural project, then you need to add material, and then analysis type. For truss, you need to select line bodies, and then in the design modeler, you need to first sketch, then convert that line to sketches, then need to add cross section, then create a part body by assigning rectangle cross section to that. And then geometry, you need to check units, that units are appropriate, and then material, you need to assign material, and then change model type. And in the mesh, you need to use mesh sizing, number of division must be 1, and then this is how to change number. And then to apply boundary condition, you need to go environment, sport, simply supported or displacement boundary condition. And to apply load, you have two options. Either you can go for vector as magnitude and direction, and then vector in terms of components. And then the directional deformation, to get deflection, you need to go to deformation directional, and to get axial force, you need to go to beam results. And then finally, your results, you can display them on screen, or then you can export them as a text file, and then you can open that text file in Excel. And then if you want to visualize that in ANSYS, so then you can use probe. Thank you very much for listening, and if you have any feedback, so you can leave in comment section.